Hello friends, continuing with the topic of transistor, today we come to its applications. Today's topic is applications of transistor. Now transistor can be used as a switch, as an amplifier, as an oscillator and as well as a modulator. Now we start with transistor as a switch. First we need the circuit. The circuit has two sections, input circuit and output circuit. First we take up input circuit. So TR is an NPN transistor in common emitter configuration. RB is base bias resistance. VBB is base bias battery. Vin is the input signal. VBE is base emitter voltage. Now we take up output circuit. RC is collector resistance. VCC is collector bias battery. VO is output signal and VCE is collector emitter voltage. So these are the names given to the various components of the circuit. Now voltage equations. Consider output circuit of the transistor. Applying Kirchhoff's voltage law, we have the following voltage equations. VCC minus ICRC minus VCE is equal to 0. From this equation we calculate VCE, which is equal to VCC minus ICRC. Let us mark it as equation 1. Now consider input circuit. Applying Kirchhoff's voltage law, we have the following voltage equation. VBB minus IBRB minus VBE is equal to 0. From this equation we calculate VBE, which is equal to VBB minus IBRB. Let us mark it as equation 2. Now graphs with input and output signals. If we plot VCE versus VBE graph and IC versus IB graphs, these come out to be as shown. This is VCE versus VBE graph. This is IC versus IB graph. Now let us discuss about cutoff state. Now consider equations. VCE is equal to VCC minus ICRC, equation 1, and VBE is equal to VBB minus IBRB, equation 2. Now when IB is equal to 0, IC is equal to 0. Now when IB is equal to 0, VBE would be equal to VBB and is maximum. And when IC is equal to 0, VCE would be equal to VCC and is maximum. The transistor is in cutoff state and can be treated as if the switch is in off state. I repeat, when IB is equal to 0, IC would be equal to 0. When IB is equal to 0, VBE is equal to VBB and is maximum. And when IC is equal to 0, VCE is equal to VCC and is maximum. The transistor is in cutoff state and can be treated as if the switch is in off state. Now saturation state. Consider equations. VCE is equal to VCC minus ICRC, equation 1, and VBE equal to VBB minus IBRB, equation 2. When IB is maximum, IC is maximum. When IB is maximum, VBE is minimum. When IC is maximum, VCE is minimum. The transistor is in saturation state and can be assumed as if the switch is in on state. I repeat, when IB is maximum, IC is maximum. Now when IB is maximum, VBE is minimum. When IC is maximum, VCE is minimum. The transistor is in saturation state and can be assumed as if the switch is in on state. Now assignment 14, question number 60, A part. Draw the transfer characteristics of a base biased transistor in common emitter configuration. B. Explain meaning briefly of the term active region in these characteristics. C. For what practical use do we use the transistor in this active region? Question number 61. What do we understand by the cutoff, active and saturation states of the transistor? In which of these states does the transistor not remain when being used as a switch? Thank you so much. Next time we'll take up next part of it. Till then, goodbye and good luck to you.